Hey guys, Persistent Programmer here and welcome back to my channel. So in this channel we solve a lot of algorithms and go over Leetcode questions. So if you haven't subscribed already, go ahead and hit the subscribe button, smash that like button because that helps me create this content for you guys. So without further ado, let's go ahead and look at today's problem. Today we're looking at the problem search in a rotated sorted array, and we're given a list like this with a target, and what we need to do is find out the position of this target if it exists in this list. So we can see that this target 0 exists in position 4 here, so we simply need to return this position 4 as our answer. But if we were given a element as a target that's not in the list, for example, if our target was 3 and this is not in the list, then we would need to return -1 since this is not found. So there's a few things we need to keep in mind for this question is that we need to solve this in O log n time. And also the way this list is given to us is it was originally sorted. So it was like this before, but what happened is this part of the list was taken and moved forward over here. So this is how we got this resulting list that is given to us. So everything was sorted at one point, however, it was reorganized in this type of way. So the end of the list was brought in the beginning. Okay, so how do we solve this in O of log n time? Well, if this list was sorted in the correct order, we would use binary search to find our target. But what we know about this list is that it was previously sorted and there is still an increasing order in this list because the higher part of the list was moved forward, right? So at some point in the list, there will be an increasing order. So we can use binary search or the principles of binary search to locate which part of the list we do want to search. And binary search is all about eliminating the search space that we don't want to search in. So in this example here, we can see that if we're looking for 0, what we need to search lies in this part of the list. So now the question is, how do we know which part of this list to search, right? So what we can see here, there is an increasing sequence from 4, 5, 6, 7, and then we have a decreasing sequence here, right? That goes back to 0 and then up again, 1, 2, 3, and 1 and 2 here. So we can see that there's a pivot here at 7, right? Which is our first mid. So what we can do here is we need to determine, is this 7 greater than our leftmost element, right? And then we're going to check if our target, which is 0 in this case, lies between, if target is between these two numbers, right? And if it's not, then we know for sure that it is on this side of the list, this other side. So we're going to narrow down our search space here. So that is the first case we're going to search. And there could be a case where the mid is here, let's say, and then this is our left and this is our right. And what we need to do here is check, okay, well, 2 is not greater than 5. So what this tells us is there is no increasing sequence here on this side of the list. So the increasing sequence is actually on the other side of the list, right? So do you see how we're using this mid element to compare it to the beginning of the list and check if there is an increasing sequence on this side or if the increasing sequence is on this side? So that's what we're doing first. And then the next step is really to check, hey, does the target lie within that increasing space, right? So here we're checking, oh, does our target, let's say our target is 1 here, and we're checking, does 1 lie in this increasing space? Because that's something we can search, right? So if target is in between, target is greater than 2 here and less than 4, we can definitely see, okay, is it here? And if it's not here, all we're doing is canceling this out and we're moving our right pointer over here because we know for sure it has to be on this side of the search space. So I hope that gives you the idea of how to solve this and the intuition behind this problem. Now we're gonna go and dive into the code. Okay, so I'm back in Leetcode, and what I've done here is I have created the left index here at position 0, and then we have our right index at the last position. And what I'm going to do now is create a while loop. So while left is less than equal to right, what we want to do first is check if the target is the mid. So let's say our target is 2, right, already. So we want to return that. So we can say if nums mid equals target, we want to return that mid. So this is our first condition. And then the next condition we are going to check is if this mid is larger than our first element, right? So we will check if nums mid is greater than our left, or greater than or equal to nums left, because there could be a situation where the left pointer and the mid are in the same place, right? So we don't want to ignore that case. Okay, so we are checking that. So if that is the case, then we know that this is a sort of, it's a increasing sequence that's happening. And we want to check if our target lies within this sequence. So what we're going to do here is say, okay, actually we don't need to say, I think we can put this condition up here. So if, okay, and then we can say if the target we're looking for, the target is, so again we're looking from here to here. So if target is less than or equal to nums left, and sorry, the target needs to be greater than this. So target is greater than equal to nums left, and target is less than equal to nums right, nums mid. So yeah, so this is how we check if it is between here or not. So if this is the case, that means what we need to do is we need to move our right pointer over here because we are no longer interested in this part of the list. So if this is the case, we're going to say right equals mid minus 1. Else, so else we know that if it is not in this sequence, it's going to be in this part of the list. So we will say else left is equal to mid plus 1. Okay, and the last case we want to check is, so if this is not the case here, so if we're looking at a list like this, right, where the left is actually greater than our mid, right? So if that is the case, then we know that the increasing order is on the other side of the list, right? So we are going to check if our target is in this part of the list or not, right? So we will say that if, so again, we're checking between here and here. So we can say if target is greater than equal to mid, and target is less than equal to nums right. Okay, if this is the case, then we're going to move the left pointer over. So left is going to be equal to mid minus 1. else right is going to be equal to mid plus 1. Sorry, here in the left we actually want it to be mid plus 1. Yeah, so we know that it is in this part of the list. So left is going to be mid plus 1 and right is going to be equal to mid minus 1. Okay, and lastly what we're going to do is return -1. So this is the case if we don't find that the target is not in the list. Alright, so this looks good. Let me give this a run. Oh, I forgot to define the mid here actually. So mid is going to be equal to left plus right over 2. Okay, so let's get this a run now. Okay, accepted and submit. Yay, success.